Section 4.3, some rules of probability. What we do in this section, we just add more rules to the previous section that related to probabilities, and we see how to apply them. First thing is we're going to introduce notation, and that I did mention in the previous section is P of E. The P of E represents the probability of event E to occur. P of E. So when we say find P of E, means what's the probability that event E will occur. So that's what P of E is. And the first thing we're going to talk about here, the special addition rule. The special addition rule says if two events are mutually exclusive means they are disjoint. Disjoint graphically means like this. They are disjoint, event A and event B. Then the probability of A or B, or means addition, or B is the probability of A plus the probability of B. And this works not only for two events, for n number of events. As you can see, the probability of A or B or C or etc. is the probability, is the sum of their probabilities. Now, also let me add here, if it goes the other way around, if probability of A plus the probability of B equals the probability of A or B, then we can say A and B are mutually exclusive. Events. And also in this case, also the probability of A and B, and where they overlap, there is no overlapping, is really zero. Is zero. The probability of A and B is zero. What can be an example on this? How do we apply it? Let's look at an example. Let's say they give us a table of values. Let's say we have a set of numbers, repeated numbers here and there. And each number has a probability of occurrence. So this is the probability, that's the number. So 0, let's say the probability for this one to happen is this, or to be selected. Next one is given 0.125, 0.097, 0.079, this number here 0.067, the next number is 0.058, next number is 0.051, and the last number is 0.046. So tight here, 0.046. These are the probabilities. We can ask to find the probability of selecting 1 or 2. So they want to find the probability of getting 1 or 2. They are mutually exclusive. They have nothing to do with each other. So it's the probability of 1 plus the probability of 2. Probability of 1 is 0.301. The probability of 2 is 0.176. And if we add them up together, that gives us 0.477. For B, what's the probability of getting at least 6? At least 6. This means they're mutually exclusive, so it's going to be the probability of getting, the number will be 6 or 7 or 8 or 9 or 10. Is there 10? No, no 10, up to 9. So then we just add them up. 6 was 0.079. No, 0.067. The next one 0.058, 0.051, and the last one was 0.046. And if we add them up, we get 0.222. Another example on that. Let's say we have 52 deck card. So 52 card deck we have. we would like to find the probability of withdrawing a king, let's say for now, a king. Well, there's 52 cards. How many kings are there? There's 4 kings. Don't forget to reduce this by 4, 1 by 4, 13. How about if they ask us to get or withdraw a king or queen or jack? Notice you can't have a card that is at the same time king and or queen or jack. Like all of them are independent, mutually exclusive. So this is, you can say it's the probability to select a king plus the probability of selecting a queen plus the probability of selecting a jack. What's the probability of selecting a king? We just did it, we found it. You can say 4 over 52 for now. Same thing for the queen and same thing for the jack. They all have the same denominator, so you add the top ones. Let's see, both are divisible by 4. So if you divide top and bottom by 4, that gives us 3 over 13. 3 over 13. Now we talk about, scroll back up to the complementary events. Complementary, 2 events are complementary. They add up to the probability of E plus its complement, which we call it not E, add up to 1. 1 means 100%, and that's where this formula came from if you subtract this to the other side. So it's like rain, no rain. The probability is going to rain today is 10%. No rain is going to be 1 minus 10%, which is 90%. That's what the complementary events are. Now another thing we have is called the general addition rule. The general addition rule says, some people call it inclusion-exclusion principle. And this one deals with the fact that the 2 events, they share something in common, A and B. This is A intersection B. Intersection means A and B. So what it says, the probability of A or B, the probability of A or B is the probability for A and plus the probability of B, but notice how the overlapping was counted twice. That's why we subtracted. That's why we subtracted here. That's when the 2 events are not disjoints or they're not mutually exclusive. What can be an example in this? Let's say from the 52 card deck, we would like to compute the probability of selecting a king or diamond. King or diamond. Always ask yourself, can the card be king and diamond at the same time? The answer is yes. The card can be king and diamond at the same time. So in this case, the probability is king or diamond, D for diamond, is the probability is going to be king plus the probability is going to be diamond minus the probability is king and diamond at the same time. So what's the probability is going to be king? There's 4 of them out of 52. Diamond, there's 13 diamond cards. How many cards is king and diamond? There's only 1 card out of 52. So when we compute this up, we get 16 on the top, 52. Both are divisible by 4, so it gives me 4 over 13. That's called the general addition rule. General addition rule. It can be applied to tons of examples. About how we can find probabilities where the 2 events, they share something in common. Let's look at more examples. Let's say the probability examples. Probability of E is 0.25. Probability of F is 0.45. Part A, find probability of not E. Find the probability of E or F if the probability of E and F equals 0.15. So we know from the complementary events the probability not E equals 1 minus the probability of E, and that would be probability of E is 0.25. That would give us 0.75. Probability of E or F. Notice what they did. They give us probability of E and F. It's not 0. So this means they're not disjoint events. So we define from the addition rule, or the general addition rule, is the probability of E plus the probability of F minus the probability of E and F. And what does that give us? Probability of E is 0.25. Probability of F is given 0.45 minus E and F is given 0.15. And if we do the calculations, that's going to give us 0.55 simplified. C, find probability of E or F and probability of E and F if E and F are mutually exclusive. Since they are mutually exclusive, the probability of E or F is simply the probability of E plus the probability of F. And this was 0.25 plus 0.45, which gives us 0.70 or 70%. Since they are mutually exclusive, E and F are mutually exclusive, then the probability of E and F is 0. They share nothing in common. Another example, given the probability of E is 0.60, the probability of E or F is 0.85, and the probability of events E and F is 0.05. Find the probability of F. Find the probability of F. How do you do this? Well, that reminds me of the general rule, addition rule. Probability of E or F is the probability of E plus the probability of F minus the probability of E and F. Probability of E or F is 0.85. Probability of E is 0.60. Probability of F is, we don't know, we're looking for that. Probability of E and F 0.05. Now on the right hand side we can combine this and this. If we subtract them on the calculator or by hand as I'm doing now, this is 510, 0.55 plus the probability of F. Then to solve for the probability of F, just subtract this on both sides. 0.30 equals the probability of F. So out of the addition rule, they can give us any of the three probabilities and they ask you to find the fourth one. Any of the three. These are really the concepts that you're supposed to know in this section.